Okay, we want to examine this relationship first, A angle M times N over A angle N. Well, let's plug in some hard values. Let's let M be 3 and let's let N be 2. So this means A angle 3 times 2 is A angle 6 over A angle 2, which is the same thing as 1 over A angle 2 times A angle 6, which means the present value of 6 payments of 1 over A angle 2, one period before the first payment. So if we make this times 0, we need to draw 6 periods here, and each one has 1 over A angle 2, 1 over A angle 2, and so on. Now, the interesting thing to note is, what if we take the present value of each subset of 2 payments? Well, these first 2 payments, the present value of those, I can take one period before the first payment is 1 over A angle 2 times A angle 2, which is just 1. Then the next 2 guys, which is time 3 and time 4, the present value of those is at time 2 is also 1. Similarly, we have here at time 4, we have the present value of these 2 payments here, which is 1 over A angle 2 times A angle 2, which is also 1. Because in each one of these cases, we're taking a payment of 1 over A angle 2. We're taking the present value of those 2 level payments. So we multiply by A angle 2. We see the A angle 2's cancel, and we're just left with 1. So this entire expression, A angle 6 over A angle 2, is really just the present value of 1 every 2 years, with the first payment immediately. So this is the same thing as A do angle 3 at a rate of J, where J is the effective rate per 2 years, or in this case, per N, which we can rewrite as, which was shown on the actual outpost. This is the same thing as writing it 1 plus V squared plus V to the 4th, which I believe was of the same thing, 1 plus V to the N plus dot 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 all the way V to the N minus, that's M minus 1 times N. In this case, M is 3, so 3 minus 1 is 2 times 2 is 4, which is our last term there. So really a better way, in my opinion, to think about it is, basically what we've done is we've taken a payment of 1 and we've split it out over N periods, and then we have M of those N periods. So we can rewrite that as just the present value of 1 every N periods with the first payment at time 0, so that's A do angle N at a rate of J, where J is the effective rate per N periods. So what about the other expression? The other expression in question was S angle M times N divided by S angle N. Well, we can see this is going to be a similar thing. Basically, we're going to be taking our 1 at the end of each period and splitting it into the present value. So let's look at the first N periods. We're basically going to take this payment of 1 and we're going to split that up into these 1 over S angle N, 1 over S angle N, dot 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 all the way to time N. So that's 1 over S angle N. So basically I've rewritten this blue one into the greens. It's the same way. It's 2 ways to write the value of 1 at time N. I can either write the value of 1 at time N by just putting a 1 at time N, or I can put a 1 over S angle N at time 1, 2, 3, all the way up to time N. And of course, this is going to extend all the way out to M times N. So basically what we're having is this 1 over S angle N times M times N. So I can rewrite that again. This expression, these greens, are just going to be a series of 1s every N period. So another way to rewrite that would just be S angle N at a rate of, not S angle N, that's S angle M, because there are M of these N periods. So it's S angle M at a rate of J, where J is the effective rate per N periods. Just like we saw, the A angle M times N divided by N is really the same thing as A do angle M at a rate of J, where J is the effective rate per N periods.